All right, time to talk about headers for a moment. Now, when you set up a new project and you intend to link against some library or you want to build a plugin that links into some third-party application, anything that has a C or C++ API, you are going to have to deal with headers. Now, remember what we say, the pound include here is basically just telling the preprocessor that when it gets to this file, it's supposed to retrieve another text file and literally include it. Practically copy and paste the contents in here. And that's about it. Now, there's a couple differences where you see the less than, greater than, the angular brackets versus seeing includes in double quotes. That is just got to do with how the preprocessor is supposed to find the actual include. So the angular brackets normally mean that it's a registered library in the project. The double quotes mean that it might be a full path or something else. They're largely interchangeable. Now, that aside, which starts going a little bit too far into the C dev instead of just learning to build, what do you want to do here? Now, if you actually have a look at your Maya install, in my case and in most people's cases, I imagine it's going to be in your program file, so Autodesk Maya 2018 include, you can find a directory called Maya. In there, you can actually find a bunch of header files. Text might be tiny, just go into that directory, you'll see the same thing I'm seeing. And this is not part of the dev kit. This should come with your default install, or if you're writing an application and you want to include OpenGL, you'll have to find the headers. If you're using some other libraries, you'll have to find the headers. Now, the fact that in here you see Maya slash means that it wants to look into a path that does have that Maya subdirectory, and then it will look in there for this specific file. So we are going to copy the path for include, and then, as I said, you could actually drag and drop all those files all into the header files for that project, but it's easier to tell your project settings to instruct the compiler that, hey, there's an actual directory where you can look for these things when you need them. So if we right click in footprint node, you get the settings. The settings for the compiler are going to be VC++ directories, and in there you can find include directories. And in there, if you put colon and then you add the path that we're just in, I don't think you need a training slash here, or you could even go and if you want the GUI to do it and browse to a path, you can use edit, doesn't matter, same thing. Apply, you're just okay. And now that error is gone because it can finally find these headers. So these will still not compile, and we're gonna get to that as well. But the build should now have moved us one step further. And it is now not like you can see here in the minimap, there's no red, so nothing is really erroring. There's no specific compiler errors, but there is something that went wrong, which is it's giving us a warning and it's telling us C4996. This is actually a link, so if you click it, you can get to the web page that explains what the error is. And this is one of the reasons why I recommend beginners start with a well-integrated IDE if they want to explore the platform and the programming language. And it's giving us a bunch of things that might be somewhat intimidating if you don't know what it's talking about. But what it boils down to is telling you this function or variable may be unsafe. So consider using upenv instead, which is a different function, more modern one that does the same thing. Or if you want to disable deprecation, you can use CRT, secure no warnings. Now, what does that mean and how do we move past that? That means that you could actually go and set up the compiler the way you want to give it instructions. And let me see if I can find that quickly. Command line. So you could give it additional options and you could tell it to ignore warnings. Now the problem in doing something like that is that you're basically telling it to ignore those warnings flat out for everything you're doing. You might be uncomfortable with that kind of carpet solution. You might want to work more specifically. Now, always in the preprocessor kind of category, and this becomes compiler specific, so this will be very specific to Windows itself. You can do things like pragma, which means this is a compiler instruction, a very specific one instead. Warning, it will flag that the compiler needs to enter warning mode. Disable and disable these specific thing, not the whole CRT security patchy stuff, just this one for this file when the compiler encounters it. Now, If you're developing from scratch, or if you were to pick a node that doesn't need to deal with a VP2 variable like this one does, that's why you have the get env in there, you wouldn't have seen these. If this is confusing, I apologize. I wanted to actually show you a couple more stumbling blocks you might get into and how to deal with it. And the main thing is, remember, if you get an error list, you can click there. Most of the time, if the error is pretty straightforward, you will get something reasonable. Now, one more time, if we build, we should have moved past all of the compiler issues, and you can see there's now a vast number of errors, and we'll get into that next. But these are all LNK errors. So these are literally all linker errors, which means our compilation actually succeeded. So if you go into footprint here and you just do compile, that part actually succeeded. You have now successfully compiled your Swiss. It's found all the includes, it's put everything it needed, it got over its warning, and you now have an intermediate object, you have a translation unit. The linker putting all things together is now failing, and that's the next thing that we need to look at.